Welcome to the Deep Dive. Today, we're diving into David Deutsch's ideas on computation.
Oh, interesting.
Yeah, we've got excerpts from his books.
Okay.
And it looks like he connects computation to all sorts of things.
Yeah, what I find most interesting is how Deutsch sees computation as like this fundamental part of reality.
Oh, okay.
It's not just about computers, it's like woven into physics, how we create knowledge,
Yeah.
even the universe itself.
He uses some really interesting examples, too.
Oh, yeah.
Like the idea that one computer
Okay.
could simulate any possible environment.
Wow.
It's almost like he's saying we could be living in a simulation.
He uses the example of a flight simulator to explain that a
Right.
flight simulator can create like a really realistic experience of flying,
Yeah.
but it still can't defy physics, like gravity.
Oh, right.
And that tells us something about the limits of any simulation,
Okay.
even one as complex as the reality we experience.
So does that mean we could be in a simulation or...
He doesn't give a definitive answer. Okay. He's more interested in what the idea of simulation means for how we understand reality.
Okay.
Like, if we were in a simulation, there would have to be, like, a deeper level.
Right.
Beyond what we understand,
Right.
governed by whatever is running our simulated world.
Okay, so maybe we'll never know for sure.
Right.
But what about his connection between computation and how humans explain the world?
Okay.
He talked about ancient Greek astronomers and how they understood planetary motion through explanations, even before they had complex calculations.
That's a key insight.
Yeah.
He's saying that explanations themselves are a form of computation,
Cool.
even without numbers.
Okay.
The ancient Greeks were making models and theories that helped them understand the movements of planets.
So they were processing information,
Right.
making connections, building a framework.
Yeah,
That's computation.
exactly.
Okay, I see that.
And that leads to another idea. The limits of knowledge. He says that we can never be absolutely certain
Okay.
about any scientific theory
Right.
because there's always the possibility of a better explanation.
Oh, so like, even if we think we've figured something out,
Exactly.
there might be a better answer out there.
He uses the term hard to vary
Okay.
to describe good explanations, meaning if you change even a small detail,
Yeah.
the explanation falls apart.
Interesting.
But even the best explanations might be replaced by even better ones
Oh, wow.
in the future.
So are we always stuck at the beginning of infinity?
Yes.
Like he says.
In a way,
Wow.
we're always refining, always at the beginning of an endless journey.
That's pretty profound.
It is.
Okay, well, that brings us to quantum computation,
Okay.
which has got to be like the most mind-blowing application of computation.
Definitely.
Deutsch is a pioneer in this field,
He is.
using quantum mechanics to do things classical computers just can't.
It's incredible.
It really is.
They harness things like superposition and entanglement,
Right.
which lets them explore many possibilities all at the same time.
Oh, wow.
So they have incredible potential
I can imagine.
to solve problems that would take classical computers billions of years.
It's mind-boggling.
It is.
What problems could we solve with that kind of power?
Right.
But it's also a bit unnerving.
I know what you mean.
Deutsch even says that quantum computers could one day break RSA encryption,
Right.
which is supposed to be unbreakable.
By classical computers, at least.
Exactly.
Yeah.
What would that mean for our online data?
It's true. The implications are significant,
Yeah.
but the benefits are equally profound.
Okay.
Think of the breakthroughs in medicine,
Right.
material science, even our understanding of the universe.
Okay, so we're going from amazing to truly bizarre now.
Yeah.
How does he tie quantum computation to parallel universes?
It's all about the idea of fungibility
Oh.
in quantum mechanics. Basically, objects that look identical can actually become different
Really?
through their interactions.
That's strange.
It's almost like they borrow identities from their counterparts in other universes.
So I'm trying to get my head around this fungibility thing.
Okay, well,
Can you give me a concrete example?
imagine two coins that look exactly alike.
Okay.
In the classical world,
Yeah.
they would stay distinct,
Right.
but in the quantum world, they can become fungible,
Okay.
meaning their properties get all intertwined and they can influence each other,
Wow.
even if they're far apart.
So Deutsch is saying
Yeah.
this happens because they interact with their counterparts
Exactly.
in other universes.
It's like a web of connections
Right.
spanning multiple universes.
Makes you wonder if those sci-fi movies about parallel universes
Yeah.
are closer to reality than we think.
It certainly blurs the line
Yeah.
between science fiction and cutting-edge science.
Okay, so we have computation, parallel universes, and now time travel.
Oh, right.
He seems to think these are all related.
How does it even work?
I don't know. This is where it gets really interesting.
Yeah.
He says that the paradoxes we think of with time travel actually disappear.
Oh, really?
When we think about the multiverse.
I see.
So in a single universe model, going back in time and changing the past creates inconsistencies.
Right.
But in a multiverse, going to the past just means entering a different branch of reality. A universe where that past event happened differently.
I see.
So you're saying I could go back in time and meet another version of myself.
Potentially.
Living a totally different life.
Each universe represents different choices, different outcomes. And although time travel is beyond our technology right now, Deutsch thinks it's not impossible.
According to physics, you mean?
Exactly.
Wow, this is a lot to take in.
Before
we go any further.
Okay.
Let's step back.
Yeah.
And come back to computation.
Sounds good.
Remember, his argument is that computation is more than just crunching numbers. It's a principle that underlies reality itself.
Right.
It's about how information is processed.
Yeah.
How systems interact. How knowledge is created.
Okay.
And this goes beyond computers.
It does.
Shaping our understanding of physics, evolution, even knowledge itself.
Exactly.
Yeah.
As we explore his ideas further, we'll see just how much this perspective changes our understanding
of the world and our place in it.
Stay tuned for part 2.
Welcome back to our deep dive into the mind of David Deutsch. Last time, we were grappling with computation, quantum mechanics, and the multiverse. Now, I want to explore how Deutsch connects these ideas to the evolution of knowledge.
It's a fascinating journey, and one key concept is the jump to universality.
Okay, what does that mean exactly?
Well, think about how early writing systems developed. They started with simple pictograms. Each picture was a specific word or concept. But imagine trying to make a pictogram for every single word.
Oh, wow.
It would be so inefficient.
Yeah, like you'd need a library just to house your dictionary.
Exactly. And that's where the jump to universality comes in.
Okay.
Instead of endless pictograms, they started using a limited number of symbols and rules to represent like an infinite number of words.
So it's like a more general system
for
representing information, like how computers use binary code.
Exactly.
Just zeros and ones.
And Deutsch argues that this same principle applies to knowledge itself.
Oh, interesting.
Instead of just more facts, we develop more generalized explanations.
So it's about finding those underlying principles
that
connect things that seem totally different.
Exactly. It's like leaping to higher levels of understanding.
Like how Newton's law of gravity explained both a falling apple and planetary orbits.
That's a great example.
One explanation for so many things.
And Deutsch thinks this process never ends.
We're always looking for more universal explanations.
It's what drives science, technology, even art.
So computation, explanation, and knowledge are all intertwined.
Precisely.
Okay, I'm starting to see the bigger picture here.
And this brings us to another interesting idea.
Right.
Knowledge isn't just a product of the universe.
Right.
It's a force that shapes reality itself.
Wow, that's a bold statement.
It is.
How does he support that?
Think about the sun. We know it'll eventually run out of fuel.
Right, become a red giant.
And swallow up the inner planets.
Yeah, it's kind of scary to think about.
But Deutsch says that prediction isn't complete.
Oh, really?
What's missing is the future of knowledge.
Okay.
Here on Earth, I mean. If we develop advanced enough technology, we might be able to change how the sun evolves.
Wow.
We could extract energy more efficiently, or even move the Earth out of the way.
So our knowledge could actually change the fate of a star.
It highlights how knowledge has real consequences. It's not passive. It can transform the physical universe.
Okay, I see how knowledge is powerful, but how does this connect back to computation?
Deutsch views knowledge as a kind of software.
Oh, interesting.
Instructions that can be carried out to achieve goals. And just like software, it can run on different hardware.
Okay.
Knowledge can be embodied in different physical systems.
So our brains are like the hardware.
In a way, yes.
Running the software of our knowledge.
But it goes further than that.
Okay.
He thinks knowledge can also be in books, instruments, even the structures of civilizations.
So it's not limited to biological brains.
It can exist out there.
Wow, it's like knowledge has a life of its own.
You could say that.
That changes how we see the evolution of knowledge.
Right.
It can be passed down, shared, even evolve on its own.
And this leads to another key point.
Okay.
Knowledge creation is about problem solving. We face challenges, inconsistencies, gaps in our understanding.
Right.
And solving those problems fuels knowledge growth.
So it's not just about collecting facts.
No.
It's about questioning, refining our explanations.
It's about the process, not just the outcome.
That's interesting.
This process is creative.
Yeah.
It needs imagination, intuition, going beyond what we know.
This reminds me of the limits of knowledge.
Right.
We can never be totally certain.
Because there might always be a better explanation.
He calls good explanations hard to vary.
Meaning if you change them even slightly, they break down.
But even the best ones could be replaced.
By something better.
In the future. So we're always at the beginning of infinity.
Always striving for something more.
It's a never-ending quest.
For better and better explanations.
Yeah.
Pushing the boundaries of what we know.
That makes me think about the role of error in all this. It seems like he embraces making mistakes.
He does. He sees error as necessary.
For learning and growth.
It's how we refine our understanding and get closer to the truth.
So it's not about always being right, but about being open to being wrong.
And learning from it.
And that requires criticism.
Yes. It's essential
for the growth of knowledge.
To challenge assumptions, put ideas to the test.
So, testing our explanations to see if they hold up.
Exactly.
This is where the scientific method comes in.
Through experiments, observations, testing hypotheses.
Weeding out the bad explanations.
And finding the ones that are more likely true.
But even in science, there are disagreements.
Right.
Different interpretations.
Competing theories.
How does he explain that?
Science is complex, influenced by personalities, biases, and limits to our understanding. But over time, the best explanations usually win out.
Because they are more robust.
They withstand criticism.
It's like natural selection for ideas.
Exactly. The fittest explanations survive.
Knowledge creation is an evolutionary process.
Always adapting.
Constantly changing.
As we find new information.
Okay, so we have computation, explanation, the evolution of knowledge. And now, evolution itself.
You're getting it.
I see how it fits into his big picture.
Deutsch sees biological evolution as another system that creates knowledge.
Even though it's different from human minds.
It works differently, but through variation and natural selection, nature produces amazing adaptations.
Each one a solution to a survival problem.
So even designs in nature, like bird wings or a chameleon's camouflage.
They embody knowledge.
Absolutely. And this biological evolution is a kind of computation itself.
Oh, wow.
Processing information, exploring possibilities, finding solutions.
This is really incredible.
Yes.
Computation is at the heart of physics.
Right.
Knowledge, even nature.
He's describing a universe where information, knowledge, computation are fundamental.
It's a whole different way of looking at things.
And that's what makes his work so interesting.
Yeah.
He challenges us to rethink our assumptions, explore new ideas, see the world differently.
We've covered a lot, from the jump to universality to knowledge shaping reality. It's been a journey through his view of computation and its role in the universe. But before we wrap up part 2, there's something I've been thinking about.
What's that?
Deutsch really emphasizes finding good explanations. You know,
I'm right.
Being open to new ideas.
Yeah.
Questioning what we think we know. He says we should embrace the beginning of infinity. Keep learning. Keep exploring.
It's a powerful idea.
But what does that actually look like in our everyday lives?
That's a good question.
How do we put these ideas into practice?
Yeah, it can feel kind of overwhelming to think about this infinite potential for knowledge.
Especially when we're busy with everyday life.
Exactly.
Like, how do we even begin to grasp it all?
I think the key is Deutsch isn't saying we all need to become scientists or mathematicians. It's more about a way of thinking, a commitment to rationality and critical thinking that we can apply to anything we do.
So it's not about how much we know, but how we approach knowledge.
Got it.
I like that.
Think about his focus on problem solving.
Okay.
We all have problems.
Right, big and small.
From work challenges to, I don't know, figuring out a home repair.
Exactly, everyday stuff.
And instead of getting stuck, Deutsch would say, approach them with curiosity.
Oh, okay.
A willingness to look for explanations.
So asking questions.
Yeah.
Considering different perspectives.
Trying to understand the root cause.
Okay.
And being open to the fact
Yeah.
that we might be wrong.
Oh, right.
That there might be a better solution.
So, like taking the scientific method
You could say that.
and applying it to daily life.
Being curious,
Right.
observant,
Yeah.
willing to test our assumptions.
Even if we don't find the perfect answer,
Right.
the process itself is valuable.
We learn, we grow.
We become better problem solvers.
Exactly.
This goes back to what we were saying about criticism.
Right.
It's important to be open to having our ideas challenged,
Even challenging our own assumptions.
which can be hard, you know,
It can be tough,
to let go of our own ideas.
especially when we've put so much into them.
But Deutsch sees mistakes as part of learning.
It's how we refine our understanding,
Okay.
get closer to reality.
So it's not about being right all the time.
It's about acknowledging when we're wrong
Mm.
and learning from it.
And that takes humility, doesn't it?
It does.
Recognizing we don't have all the answers,
Right.
that there's always more to learn.
We can benefit from others' insights.
It brings us back to the beginning of infinity.
Yeah.
It's humbling to realize our understanding is always incomplete.
It is humbling, but it's also exciting.
How so?
There's an invitation there to keep exploring,
Yeah.
learning throughout our lives.
Okay.
Never stop questioning.
Seeking deeper understanding. I'm starting to see it that way too.
It's not about feeling overwhelmed
Right.
by what we don't know.
It's about the joy of discovery. The
Exactly.
potential for growth.
That's what he's trying to convey.
I see.
The beginning of infinity isn't daunting.
Huh.
It's an invitation to a life of possibilities
A journey of exploration.
that we can all take part in.
And this isn't just for science and technology, right?
No, not at all.
This applies to anything where we create something new.
Art, music,
Yeah.
even being a better parent.
It's about bringing that curiosity, creativity
That critical thinking.
to everything we do.
Exactly.
So maybe we can't all build quantum computers
Right.
or discover new laws of physics.
But we can all be better thinkers, better problem solvers.
Lifelong learners.
And by doing that,
Yeah.
we contribute to knowledge.
To human understanding.
We carry on the legacy of the Enlightenment.
Wow. That's a powerful thought.
It is.
It really ties everything together.
It leaves us with a challenge.
Okay.
What problems will you solve?
Mm.
What explanations will you seek?
What new knowledge will you create
Those are the questions that drive us.
that keep us at the beginning of infinity?
Exact.
Thank you for joining us on this deep dive.
It's been a pleasure.
Until next time.